Today, I'm taking you on an amazing journey on how to create your custom license plate detector using Ultralytics YOLOv8. I'll teach you how to set up the folder structure for training this particular model. In addition to that, you will learn how to source data to train your own custom models in future. Finally, I'll teach you how to run inference on this model we are going to build. There is a lot to learn in this particular tutorial, so grab your seat and don't forget your coffee and let's roll into it. Oh, okay, so before we roll into it, if you like computer vision tutorials, you like AI tutorials, you like Python programming and data science related videos, subscribe to this particular channel. Don't forget to click the subscribe button and also the notification bell icon on. And finally, do me a favor by sharing this particular tutorial with one or two of your friends. Let's roll into it again. Alright guys, so start off by looking at the folder structure we need to create your custom YOLOv8 model. So on my desktop, I have a folder here, and this folder is named Vehicle License Plate Dataset. So if you want to create your custom model, you can follow this same folder structure. Make sure you follow and you don't mix any steps so that you will not get any future errors. Okay, so in this folder, we have additional 3 folders. This is test, train, and valid for validation. So when you open the test folder, you have additional 2 folders, images, and their corresponding label folder. For now, these folders are empty, and we will soon populate this images folder with the image, and then we'll annotate it and get the labels in the labels folder as well. Okay, the same thing applies to the train. We also have images and labels, and we'll do the same thing. For the valid too, we do the same kind of thing. Then for the data.yaml file, when you open it, this gives you the path to your images. So you can see we have the train folder, and in the train folder we have the images. So this just lists the path to the images in all the 3 folders. So you can see for the test, for the val, and we have NC here. This stands for the number of classes. So in our case, we'll be detecting the license plate and the vehicles, but our main focus is on the license plate. So if you want to at least do only license plates, you can just remove this one right here, and then you change the number of your classes to 1. But in my case, I just put in the vehicles right there. Alrighty, so with that out of the way, the next thing is to get data. And for this particular one, all you have to do is to go on Google and download more images of cars with their number plates. So you just move to images and you download more images of them. You can also search for data, already made data set, and annotate them. But the fast route for you to do is to search for already made data sets. I'll show you all the procedure. So I have a folder here named data, and in here I have some images. So for this tutorial sake, I'm going to teach you how you use only 10 images so that we can be fast, but I'm not going to annotate about hundreds of images. But in your case, to train your own model, you need more images for the model to work accurately. Okay, so what we'll do is that this is 10 images, and most of the times you have to make sure your train images are more than your testing and validation images. So 80% of your images you use for training, and use 10% for validation, and also 10% for testing. So in our case, you just have to open our folder here. I'll move it to one side, and then I'll copy about 6 of the images to the train folder. So I'll copy 5 and add 1 to it, making 6. Then I'll move on to the other folders, which for the test, I'll give it 2 of the images. And for validation I'll move on and give it 2 of the images as well. Okay. But in your case, you need more images, so you have to associate more images for this particular task. But we are just using 10 images here for demo sake. Okay, now after sharing the images in all the images of train, test, and validation folders. The next thing is to annotate these images. So my favorite annotation tool I almost use is makesense.ai. So you just type makesense.ai, you enter, and right here you'll be presented with a nice interface. You just have to hit get started, and then you show the path, or you click here to show the path to your images. Okay, so my folder is here, and when I come here, I have test, train, and validation. We can start for the train because the train have many images, and we go to images, and these are the images we want to annotate. Once again, this is only 6, but in your case, you need to use as many images as possible for your model to work accurately. So I'll select all these images and click on OK. Then select object detection. Over here, you need to provide your label name. So in our data.yaml file, we have 2 labels, and the first one is license plate. You click enter. The next one is vehicle. So you just type vehicle right here. Okay. So these are the 2 labels we are coming to annotate our data for. You just have to click on start project, and then you begin annotating your images. So the first one will notate the normal license plate, and then we select the label. So the label here is license plate. You can annotate the car too as well, or the vehicle as well, because one other label is the vehicle. You can shift it, so you can drag and drop if you didn't annotate well. And in here, this label is the vehicle. So we have our license plate annotated and the vehicle annotated. So you can see we have a check mark here. We'll go to the other one and do the same. So since the focus is on the license plate, you can skip or only label the license plate, because this one, the vehicle is not showing well. So you can just annotate the license plate and move on. The next one, all you need is a license plate. You can annotate it very well and also move on. Okay, right here, we'll annotate this license plate as well. I can see a license plate right here as well. And make sure the labels are correct here. Annotate this one. The label is correct. Make sure you annotate this as well. So with this, you are done with your annotation. The next step to do is to download these annotations. So to download it, you go to actions and you have to come to export annotations. Over here, you select a zip package containing files in YOLO format, because we are training a YOLO model. So make sure you download this one. This is very important. Then you click on export. So this will go ahead and download it and put it in your downloads directory. So you can see we have it right here. I can close makesense.ai right here. And these are our annotations. So what you can do is to open your data folder, which is right here, and these annotations are for the train label. So you open train and then you open labels and copy all these annotations and paste it inside. So these are the annotations for the label images. So we have the images here and they are corresponding labels. The next step to do is to annotate for the other ones. When I mean the other ones, you have to annotate for the test as well. So you can see we have images. So for labels, you have nothing. So you have to still use makesense.ai. And to do that, you can just refresh so that you begin afresh. So you can reload the page and you get started. But for this time, we are going to do it for our test images. So we go back, and then we select test, we select images. So it's only 2, but in your case, you are using more images, so you have to. So you go through the same process. You type the label names, which is license plate. You hit enter, and then you type vehicle as well. You hit enter. You don't really need this. Start project. So you still need to annotate these 2 just like this, and you make sure we choose the label in each case. Okay, so I think this one, the vehicle is visible, so we can annotate the vehicle too as well. but our main priority is on the license plate. So just like this, and then you select vehicle right here. So you still need to export this one. So you just click on actions, import annotations or no export annotations. You select the zip format, hit export, and this will download right here just as the one we did. So you have to do this one for the validation folder as well. So at the end of the day, you just have to do all of this for your labels. So right here, let's bring in that label from our downloads folder, and this is the last label we've downloaded. So it's only two. You just have to copy it and paste it right there. So it's in the text and labels, then we paste the two labels right here. Okay, so after pasting, you need to go ahead and do the same process for the images in the validation folder. So we have two here. You have to label them or annotate them using the makesense.ai and have their corresponding labels here as well. And with that, we are done. So that's the folder and data structure you need to train your custom model. So make sure you follow the same step. Make sure you have many images, because the more the images, sometimes the model perform much better. So have many images, and you can also search for already made datasets. We have datasets that have been already annotated, but what I found out is that most of these already annotated datasets, sometimes they are not in the YOLO format. So you need to re-annotate them or process them in that particular format before you can use them. But in my case, I have to download my own data and annotate them and make sure that everything works. So you follow the same process to download your data, annotate them, put them in this particular folder structure. You have your main folder here on desktop, and then in this folder you have this particular folder structure in them. After this, what you need to do is to open your Google Drive and export these folders. So I'll quickly open Google Drive, click here and open my Google Drive, go to my folders, and you can see right here that I have that particular folder here. So you can see license plate dataset. You can open it, and when I open it, you can see I have the same structure: validation, train, test. And if I should open train, I have the same labels and images. In my case, when I open images, I have many images. So you can see I'm using many images to train the model so that it will work better. After this, we'll be using Google Colab to train our model. That's why we are uploading the model on our Google Drive so that we can access it in Google Colab. So you open your Colab, and all you have to do is to mount your Google Drive and connect to the free GPU that Google Drive provides. So when you click here, you can see change runtime. Then you can see it's not on our CPU, it's in this particular free GPU that Google Colab provides. So you just have to save, and we have to do some couple of installations and train our model. So with that, the first thing we need to install is Ultralytics. So exclamation mark pip install Ultralytics. You hit install, and this will go ahead and install all the packages you need from Ultralytics. Okay, so now our installation is done. We have gotten our check mark. We need to import YOLO from Ultralytics so that we can use this YOLO instance to train our model. So one thing I love most about Ultralytics is that you only need one line to train this particular model. The first line, we are installing the Ultralytics library. The second line, we are importing YOLO. And the third line, we are training our model. Okay, so what you need to modify here, which I'll make sure this notebook is available for all of you, but it's only some few lines of code though. You need to go to your drive, open my drive, then you locate your data set, which is right here. So let me expand this so that you can see. So vehicle license plate data set, and over here you come to the data.yaml line. You click on these three dots, and you have to copy this particular path. So this is the path that will lead you to our images, our classes, and we'll use this in accessing these images so that we can train our model. So to train the model is very simple. We have YOLO. The task here is to what? Dictate, because we want to create a detection model. The mode here is to train. We want to train. We are not running inference, so we want to train this model. And the particular model we are using here is the YOLOv8s. So YOLOv8 has some variation of models. We have large, we have medium, we have nano, and we have small. So the large model is very big and you need graphics card to run it, and it performs well. So the higher the model, the accuracy is better, but the latency now becomes a problem. So if you have a graphics card on your computer, you make sure you can choose the large or medium model to train. But in our case, I'm going to use small. You specify the confidence, which is 0.25. Then the data, here is where you have to paste the path you've copied. So right here, we can just select here like this up to where the YAML ends, and then you paste your path right here. Okay, now the next thing is the epoch. So I'll specify 200. You can specify more or less. That's the number of times this model will train. So when in the training process, when this model doesn't perform, it stops automatically for you. It doesn't continue to train, so you don't have to worry. So you can put higher number of epochs here, but when it trains like 100 epochs and there is no improvement, it will stop automatically and you get your model. The image size we do is 640, and that's it. So now we just have to hit this cell, and this will go ahead and download the model weight and access our images and start the whole training process. So you can see everything right here. So over here is scanning our images in the validation folder, and the training process have just begun. So 1 out of 200 epoch. So guys, I'm not going to wait for this whole training process to finish before we continue, because I've already trained this model and I have the model downloaded. So I'll show you how to access your model when the training process is done. And for that, you just have to click on these files and you go to runs. So you click on the runs, you go to detect, you go to train, and then over here you click on weights, and these are your models. So we have the last.pt and the best.pt, and your best.pt is your best performing model. So all you have to do is to click here and download it, and this will automatically be downloaded into your downloads folder, and all you have to do is to move it into your Python IDE directory that you are using so that you can use it to run inference on videos. So I've downloaded my model I've trained beforehand, and this model is right here. So I have a folder here. So this is the model. I've named it normal plate model.pt, and I have this code right here that we use to run inference. So let me open it up. Okay, so this is the code we use, and I have the model in the folder just as I've showed you, and I'll go through this code briefly because I have a video on my channel which is right here at the top where I teach you how to run inference using YOLOv8 in your IDE. So it's kind of the same type of code we are using, so I don't need to go through that much because you can check that video and have in-depth understanding of how everything works. Okay, so over here we have some imports: OPCV, CV zone, math from Python, and the YOLO from Authoralities. So you have to install these libraries, and all you have to do is to open your terminal, which I've opened here, and you have to type pip install. Then the first library is Authoralities, and you hit enter. So I've already installed this. Okay, it seems some things are still installing, so it will install these packages for you, and then you can use it to run inference. You just have to do the same thing for the rest of the libraries so that you can install all of them. So for OPCV, you do the same thing: pip install OPCV Python, and this will get it installed for you. I've installed all of this, so you can even put them on the same line. You separate it by comma and also write CV zone so that it will install all these libraries for you. Alright, so now I'll take you through the code to see how the code works. So this is just a code for running inference using the YOLOv8 model. Okay, so right here we do our import. We import OPCV, which we'll be using to read our video file. CV zone just to display some text, and the math module we use it to do some computations. Then we are reading the YOLO model from Authoralities, and that's what we use to create a YOLO instance to run our inference. Okay, and over here I'm just reading in some videos. So I've read in 5 videos, and these videos are on my desktop in a folder called computer vision. So I usually have some videos here I use for running inference on computer vision tutorial. So I have the videos here and I've just loaded some of them, and that's the paths you are seeing right here. So I've loaded these videos, and over here I'm creating a capture object. So CV2 video capture, and I'm giving it the video I want to read. I've created a YOLO instance here, so YOLO, and then in here you pass the name of your model. So right here I showed you that my model name is number plate model.pt. So make sure the name you use to rename your model, you put it right there. When you download the model, it will be best.pt as I showed you, but when you rename it, you can rename it to any name at all, and make sure you put it right here. After this, we create a list called class names, and these class names are the classes. So remember, before we annotate them, we have two classes: license plate and vehicles. Since it's a video feed, we create a loop. We take in our frame right here. We resize this frame to some particular dimension, which you can change in your own use case. And then we feed this frame into our model. So over here, we are just looping through the results from this particular YOLO model, and we are getting our bounding box, our confidence, and particular class name detected. And in here, we are getting our coordinate, the bounding box coordinate on each and every detected object. So we are just converting them to integer because by default it's a floating point value, and OPCV for drawing rectangles, it requires integer values. All right, so we check if our confidence is greater than 50 and the class detected is license plate. Well, we know two classes will be detected. Right here we have vehicle and license plate, where we are only focusing on the license plate. So if our class detected is a license plate, we'll go ahead and draw the rectangle, and we use CV zone to put the text of that particular class, in this case license plate, on the particular object detected. All right, so over here we are showing it the window name, and then since it's a video, we are taking each frame 1 second, and if you press T on your keyboard, you will just release your capture, you destroy all your windows and everything close up. So this is literally the code we are using to run inference, and if you want to understand this in depth, I have tutorials on how to run YOLOv8 in your IDE in my computer vision playlist right on YouTube. So what I'll do next here is to run this code so that we see how this model perform on these videos. So I'll run it with the first video, which is vid1, and we'll see how it performs. Okay guys, so you can see how it's detecting the normal plate accurately. So I think you can see this model works great. I'm also impressed on how it turned out, how it's performing. I just love it. So this model will be available for all my patrons, together with the dataset will be made available for them to use. If you want it, you can join my patrons so that you have access to this particular model and the files. I'll also in time increase the accuracy of this model by fine-tuning it on various data so that I'll see how it performs. Anytime I have a new version which outperform this, I'll post it right to all my patrons. So if you want it, you know what to do. Link is in the description. Okay, so I'll run it on the second video and let's see how it will perform. And here we go guys, you can see the model is performing and it's doing an amazing job. So the model works overall and I'm impressed on how everything turns out. So I like it. I don't know, but I just like this particular model. Okay guys, so let's run this on the video 3 and we'll bring this tutorial to the end. You can test this with your own videos to see how it performs on them. So I'll run this on the video 3 and let's see how it will perform. And here we go guys, you can see how this is detecting these plates. So you can see it's still working fine. It's still detecting as usual. Alright guys, so as shown, you can see this model is working great. If you like this video, make sure you give me a thumbs up. You leave your comments in the comment section and also share this video so that we build an amazing learning community together. I love you guys all and stay tuned for the next tutorial.